Hello, welcome back to Chapter 13, Section 5, the Law of Sines. And we are going to do 6 problems where we're going to solve the triangle using the law of sines. And notice they don't all have to be called triangle ABC. What I need is a side and its opposite angle for the law of sines to work. First thing I like to do is I like to make a list. So here I've got JKL. So you get the measure of angle J, which is 40 degrees. There's one of them. The measure of angle K, which is 85 degrees, and the measure of angle L, which we're going to figure out because they all add up to 180. Then I've got side J, which is this one, which is 8. So now I've got my angle and its opposite side. I got my side K, which I don't know, and my side L. And notice they switched the cursive L because print L looks like 1. All right, cool. So first let's find angle L. That's the easiest one. All 3 of these have to add up to 180. You can add these, subtract from 180, however you want to do it. I usually just do 180, subtract the first one, then subtract the second one. So I get 55 degrees. And I can add them again. I almost said re-add. I can add them again to double check, make sure I got 180. Now I want to find side K. I can do sine of 40 degrees over 8 equals sine of 85 degrees over K. That's the actual law of sines. But remember, we also said you could use the reciprocal of that. I can just flip everything. So I'm going to use side K over sine of 85 equals side J, which is 8, over sine of 40. And that straight up you can do on the calculator. Multiply that times that. 8 times sine 85. Don't forget to close your parentheses. It'll give you the wrong answer if you don't. Because when I hit divide, I need that divide to be outside of the parentheses. I'm going to divide by the sine of 40. And that gives me, let's see, it says round to the nearest tenth. That gives me 12.4. And I don't have any measurements. I had to double check because I forgot it last time. All right, now I can now use this to figure out this one, but I'm not going to. Always go back to what you were given. So now I've got side L over 55 degrees, sine of 55 degrees. And again, even though I calculated to find that, I know it's going to be accurate. 8 over sine of 40 degrees. And this solving for L is going to look the same, except I'm just using a different angle here. So I've got 8 times, excuse me, a little disturbance down here. 8 times sine of 55 divided by sine of 40. And again, rounding to the nearest tenth, the 0.19 is going to give me 10.2. Okay, there's one. Here's number 5. That was number 4. So now I've got angle XYZ. So I've got the measure of angle X, the measure of angle Y, and the measure of angle Z. Which ones were I given? Angle Y is 28 degrees, and angle X is 112 degrees. So we're going to add to find out angle Z. That's easy. Side X, side Y, side Z. And I usually draw lines through the Z's so they don't look like 2's. Angle Z is here. Here's X and Y, which we don't know, so this has to be Z, which is 25. All right, let's hit clear. Let's find angle Z. So I got 180, subtract 112, subtract 28, and that leaves 40 degrees for the last one. I have to use that because that's opposite of my side that I know. So I'm going to solve for X. So X over the sine of angle X, which is 112, is going to be Z, which is 25, over the sine of angle Z, which is 40. 25 times sine 112, close your parentheses, divided by sine of 40, and to the nearest tenth, the 0.06 is going to go up to 0.1. So this is going to give me 36.1. And again, no units here, so I don't know what that is. Finally, for y, side y, the length of side y over the sine of angle y, which is 28 degrees, is going to be 25 over the sine of angle z, which is 40 degrees. And notice this is the same as that. It's the same ratio that I'm using. So what I'm going to put in here is going to be exactly the same, except there's going to be a 28 there instead of 112. 25 times sine 28, close your parentheses, divided by sine 40, and looks like I got 18.25. To the nearest tenth, that'd be 18.3. So I had 3 parts of the triangle, and I was able to figure out the other 3. Cool. Number 6. So now I got triangle DEF. So I got measure of angle D, measure of angle E, measure of angle F, and side D, side E, and side F. What do I know? Angle D is 47 degrees, angle E is 68 degrees, angle F we don't know, we're going to figure that out first. F and D we don't know, this is E, E is going to be 3, and angle E is opposite side E. So that's going to be the ratio that I'm using. That'll be good. Let's figure out what angle F is first. I guess I could figure out what angle D is now since I already have my ratio, but that's okay. I'm going to take 180, subtract 47, subtract 68, and angle F is going to be 65 degrees. All right, now let's see. I'm going to look for side D. So side D over the sine of angle D, which is 47, is going to be side E, 3, over the sine of angle E, which is 68. Multiply that times that. So 3 times sine 47, close your parentheses, divided by sine 68. And looks like I get 2.36, so we're going to call it 2.4. And then we'll do the last one, side F over the sine of angle F, which is 65 degrees, and go back to what I have here. Even though I can use this one, go back to the one I'm given, which is 3 over sine of 68. And notice this ratio here is the same as that ratio. So 3 times sine 65 divided by sine 68. And 2.93, the 3 isn't enough to move it up to the next level, so we're going to call this 2.9. All right, now those 3 all kind of started out the same. The next 3 are going to be probably slightly different. They're going to mix it up a little bit. And the reason why I say that is because they're not going to give us the ratio. So I'm going to have to figure this out. But basically they're all going to be okay. This is ABC. So I got the measure of angle A, which is 41 degrees. Measure of angle B, which is 74 degrees. And the measure of angle C, which we're going to figure out. Side A, we don't know. Side B, we don't know. But we do know side C, which is 2.7. So again, I have 2 angles. I can subtract from 180 and get the third angle, so I get 65. These 3 add up to 180. So I'm going to use this as my ratio. So A over the sine of angle A, which is 41, is going to be C, which is 2.7, over the sine of angle C, which is 65. 2.7 times sine 41, close your parentheses, divided by sine 65. I got 1.95. The 5 actually does make it go up when I'm looking for A. So even though it's like 1.95, I do have to round it up to 2.0. And the last side, side B over the sine of angle B, which is 74 degrees. Same ratio that I used, 2.7 over sine 65. 2.7 times sine 74. You know, I keep saying close your parentheses. To be honest, it's to remind myself to do it. But it's also good for you to know too. Divided by sine 65. And I get 2.86, so that's going to give me 2.9. I know it's like 2.86, but the 6 is going to round the 8 up to a 9. Alright, 2 more for this one. We'll try to keep this video under 20 minutes. Haha. So I got the measure of angle F, the measure of angle G, and the measure of angle H. H is 63 degrees. G I don't know. I'm not going to say anything. And F is 35 degrees. And side F is 14. Had to trace with my finger so I wouldn't lose. Side G I don't know, and side H I do not know. So let's find angle G. So 180 subtract 35 subtract 63 gives me 82 degrees. My ratio is going to be side F over angle F. So let's find G first. That'll be G over sine of 82 degrees, angle G, G over G. And F, side F is 14 over the sine of angle F, which is 35. I wrote 14, sorry, 35. That's what happens when I'm thinking faster than I write. Okay, so I got 14 times sine 82, close your parentheses, divided by sine 35. And that gives me 24.17, which rounds up to 24.2. And the solve for H, side H over the sine of angle H, which is 63 degrees. And that's still going to be equal to 14 over sine 35, which is side F over sine of angle F. 14 times sine 63 divided by sine 35. And we'll call it 21.7. And I know I'm going fast because I know that a couple of the videos have been a little bit long, and I'm aware of that. So if you do need to pause or rewind or something, please take your time and do that.